Alright, Math 3, Trig final review. So, things to remember about graphing cosine and sine. Okay, the basic format of the equation is f of x equals a, our amplitude, times the sine or the cosine of b. And I use theta. You can use x or theta, same thing. If you're using a graphing calculator or Desmos, you want to use x plus the midline shift. Now, to find the period, okay, it is 2 pi divided by b. So, for number 1, I have an amplitude of 1/2. Okay, my normal amplitude is 1. Okay, this would be like 1 over 4, so I'd go 2b divided by 1 over 4, which, or 2 pi, not 2b, be divided by 1 over 4, which we flip it and multiply, would be 4 over 1. So basically, our period is 8 pi. Remember, the period is how long it takes to repeat itself. And then our k is that midline shift would be 1. So that midline shift means positive 1, we shift it all up. Now normally the midline is on the x-axis. And so normally your cosine graph starts at 1 and then it drops down about 90 degrees or pi halves, then down to -1 at pi, then 3 pi halves, and back up at 2 pi. So it normally goes like that. And those are the 5 points we usually deal with. But we've stretched it out quite a bit doing this. We've also bumped it up 1, but our amplitude is 1/2. So starting at this midline, instead of going up to 2, I start at halfway. And then I also end halfway, because notice that I started and ended at the same place for the parent graph. So I end at 8 pi. Okay. Now, halfway between pi, we went down -1. So halfway between, which would be 4 pi, we go down 1/2. It would look like that. Okay, then halfway between that, we hit the midline. So halfway between that would be 2 pi and 6 pi. So it would look like this. And there's our first graph. Now you may be thinking you want to just use Desmos for this. So here's a few tricks. Alright, so here's a screenshot. So I typed it in just like I saw it. Notice instead of theta I used x. Okay. Then there's a cool thing you can do. When you click on here, I went to projector mode, of course, but then notice how I changed my way that it worked. I matched that information here, okay, on the y and the x's. So what we see here is actually that same amount, okay? I was able to change that to work so it would match up, and then when I hit all those points, it tells me exactly where they're at. But you've got to make sure you're using pi, which if you hit the little thing here, you can find pi in the sine and cosine. So if you're using Desmos, make sure you change the window so that it makes more sense. Alright, so let's take a look at number 2 now. I'll do it by hand and show you how I graphed it. Not by hand. So a sine function normally starts at the origin, and at pi halves goes up to 1, then pi, then at 3 pi halves, and then at 2 pi, and it looks like that. For ours, our amplitude is still 1, because there's a 1 in front. Our k midline shift is 1, so we're bumping everything up 1. But then our period would be 2 pi over 2, which would just put us at pi. So we're going to cover the same distance in half the time. So we start up here, because we shifted up 1. Then instead of going out to 2 pi here to end, we're going to end at pi. Let's actually make this purple. Then if you'll notice, start to end exactly in the middle is when we hit the midline again. So exactly in the middle we hit the midline again. Then in between the first two we put a point up here. In between the second two down 1, because our amplitude is 1. And there's our new graph. Now once again I went on to Desmos and I typed it in. I went up here and I changed the settings again to only go as far as 2 pi. So from negative pi fourths to 2 pi, I had it count by pi fourths because that's what it was counting by in my step. And then notice my midline would be right here. And we can see all these important parts to it. Okay, and right here is where it would repeat. I didn't put that point or that point, though I should have. Okay, I should have made the midline. Now, if you didn't want to use Desmos and instead wanted to use a graphing calculator, you go to Graph. You can go to Window Zoom and hit Zoom Trig. Notice negative 6.28, that's like negative 2 pi. It's like positive 2 pi. Okay, but that doesn't look quite the same as that one, does it? So I can go back to Window Settings, and I can change them to those same type of settings that I wanted to use, just like I saw here. The y values, the x values, and their scales. Okay, when I do that, see it matches more closely to what we saw up there. And those points would correspond with the points on the graph, the grid. So that's a great way to do it too. Okay, so either way you do it, graphing it by hand or with technology, you need to make sure you have the right window. That's the key. So let's take a look at 3. So now we've got 2 plus, so our midline is at positive 2. So positive 2, we draw our midline. Okay, our amplitude is 4, so instead of just going up 1, we're going to go up 4 from that midline and down 4 from that midline. And then our period, we go 2 pi over 4, which would be pi over 2, which means we're going to complete a whole cycle in pi halves, which is essentially 90 degrees. So we start up here at our new midline because of the shift. We're going to end right there at pi halves. So basically every pi halves, it's like we're going to be repeating. Okay. Then halfway between that at pi fourths, we're coming back. So in between those, and we got to go down and up 4, don't we? So I'd go up here to 6, and then down to negative 2, so it's going to look like this. And that's what it would do. That's what it would do over and over. Okay? And there's that one. So on Desmos again, there's my midline, so we start up here, and then at pi halves we end. Okay, in between that pi fourths, and then in between those two we go up 4 more. So that's pi eighths, down through, down 4 more, 3 pi eighths, and back up. And typically we only need to have one piece done like that. Alright, then the last one is a cosine, and once again the cosine, it starts up here at 1 and ends at 2 pi up there at 1. Pi, it's down to negative 1. I totally missed that. And then in between at pi halves and 3 pi halves, it hits that midline, so it looks like that. Somewhat like that. Let's see if I can draw that a little better. Okay, so ours, we have an amplitude of 2, so we're bumping up 2 higher. Our period would be 2 pi over 2, which would just be pi. So we're going to start and end in half the time, and a midline of negative 1. So we drop it down negative 1. From that negative 1, we're going to start up 2, so we actually start at the same place. Okay, and we're going to end at 2, but we end at pi at 2. Then halfway, at pi halves, we go down 2, and we hit the midline in between those, and it'll look like that. And that's what our new one will look like. And if I graph it on Desmos, it looks like this. Okay, midline at negative 1, start up 2, go down 2, end right there, and all those important points that you can see. Alright, so there's graphing by hand. Now, if we're going to write the function, okay, so we've got to try to figure out a few things. We want to know where the midline is, we want to know what the amplitude and what the period is. Okay, so if I look at number 5, cutting in between looks like at 1, that's where my midline is, which means going up and going down, we have an amplitude of 2, and then we start, looks like from that midline we start on the midline, which would tell us that that's going to be a sine function. And then we go until we stop, and we stop at 2 pi. So our period is 2 pi, which we need to figure out what b is. So b is, or period is 2 pi over b. We know that our period is 2 pi, so what's the only value for b to make this work? Well, it'd have to be 1, wouldn't it? Because if we cross multiplied, 2 pi times b would equal 2 pi, divided by 2 pi, and we'd get 1. So b would equal 1. So now I can write it. So I'd go f of x or y equals my amplitude, 2, times the sine of my b, 1, so I just leave it, and do x or theta, then my midline plus 1. And there's my equation. Okay, now number 6, same idea. Notice I dropped clear down to -3, so k is -3. Once again, we're starting right here, so we're going to have a sine function. My amplitude is only 1. And then how long does it take us to go through? From start to finish is 2 pi. So my b, my period is 2 pi, which means b is also going to be 1. So I go f of x equals 1 times the sine of x minus 3. And there's my second function. Okay, now these last two. Says Cassie played a note on her guitar that had an amplitude of 2 and a frequency of 196 hertz. Write a sine function to describe this note. Now, for frequency is kind of the opposite of period. So it's actually b over 2 pi. So, frequency of 196, I'd go 196 equals b over 2 pi. So times by 2 pi. So whatever 2 pi times 196 is going to be my b. And because it's a frequency, I can leave it as pi, and typically that's what they like to do. So 196 times 2. Get my calculator. I can probably do that in my head, but I'm not going to. So 392 pi. So it is b and an amplitude of 2, and it's a sine function. So I go f of x equals 2 times the sine of 392 pi x. There's no midline. That's my answer. Okay, number 8. A snare drum has a frequency of 500 and an amplitude of 5. Write a sine. So I go f of x equals 5 times the sine of, well, if we did the same thing, b over 2 pi equals 500 times by 2 pi, we're going to get 1,000. Let's write it down here. F of x equals 5 times the sine of 1,000 pi times x. And there's my function for that one. Alright, and that's pretty much it, guys, and there we go. Another one down.